Well, I was asked to do a breakdown of the unit circle, so I'm going to do as much as I can in as short a time as I can so that we don't take too much time on the video. So we'll just jump right into it. As of now, we've got we've got degrees only. We're going to deal with radians tomorrow on Tuesday. But for now, if we started and we knew that we started counting here, we'd be at 0 degrees, and we'll eventually get all the way around and finish up there as well. We'll talk about that in a second. But if you recognize that we have 30 degrees right here, then that right there is 30 degrees. And we have these smaller steps in between. Those are 15-degree increments. So once you get to that first spot, the lowest spot, what I call the short triangles. The short triangles are 30 degrees from the x-axis in all directions. So if I kind of come over here and talk about the short triangles or the bow ties, all of these are 30 degrees from the x-axis. Okay, so you can kind of talk about them all at the same time, and in radians, those are going to be easy to identify. But 30 degrees in all directions here, you go 30 degrees back, you'll need to know what this is. Half of a circle is 180 degrees. And so if I go back from 180 degrees, I'm at 150. 180 minus 30. Well, what if I do 180 plus 30? That's 210 degrees. Okay. I can go all the way around to near the end. I already talked about all the way around is 360, right? Well, if I go back 30 degrees from that, I get 330 degrees. So those are all my short triangles, my bow ties, or however you want to think about it. Okay, and I've jumped to those to try and get some sort of connection between those. If those are where you start in every quadrant, that's fine, because you've got your low triangles, and now you can add 15 to 2 steps and you'll fill in all your triangles. You're going to add 15 to 30, you get 45. You add 15 to that, you get 60. Okay. Now I said add. You're going to stack, I guess, stack 15, but recognize you're going backwards around the unit circle. So you're actually decreasing 150 by 15, which brings you down to the 135. You decrease by another 15, you're down to 120. So those are your incremental steps, the 15-degree increments. Now, most of us know that you go straight up from straight over and you're at 90 degrees. So you can always do that same thing where you've got from here to here is 30 degrees, 60 to 90, and from here to here is another 30 degrees, 120. Okay. So from every access point, whether it's x-axis or y-axis, you go any direction, you're going 30 degrees from that location. You're going to identify a specific point on the unit circle in degrees. Okay. Down here, you add another 90 degrees to 180, you're at 270 degrees. You subtract 30, you're at 240. You add 30, you're at 300. Okay. And again, once you're there and you've identified those things, it's 15 degrees from here to here and from here to here. So I can add 15 to that to get 225. I can add 15 to that to confirm that this is 240. I can add 15 to this. I get my 315. And I add 15 to that, I confirm as well. So there's your degrees all the way around the unit circle. That's done, that's complete. We have spent some time explaining about the measure of the short side of a triangle. The short side of a triangle doesn't always mean it's the height of it. Short side of a triangle in this case here is 1/2 because that's much shorter than this distance all the way over here. That right there, whoa, almost came up short, is the square root of 3/2. Now I want to point out, and this is tricky to do, the distance from here to here, this is a tall triangle. The tall triangle has the same dimensions. They're just positioned in a different way. That right there is the square root of 3/2, and then the short distance here is the 1/2. Okay? So when you identify the x and the y values, the long distance followed by the short is our x and our y, and if this is 0, 0, then to go over and up, I'd have to go over the square root of 3/2, and then I'd have to go up the 1/2. Okay? Same triangle, different orientation. I'm going over the short distance, then up the big. So that's why this is 1/2, and then come the square root of 3/2. That is going to be true about every short and tall triangle all the way around. But you know what? I've identified the bow ties. Let's go and do that in every single quadrant. Okay, I went over the long distance, up the short distance. That's root 3/2 and then 1/2. Root 3/2 and 1/2 is the same exact thing again. The difference is in this quadrant, you're first going negative, then you're going positive. So this is going to be the negative square root of 3/2, which is the long distance back, and then the short distance 1/2. If you go to another bow tie, it's going to be exactly the same the same values. You're going back the great distance, you're going to go down the short distance. So negative root 3 over 2. This time it's a negative 1/2. Everything in this quadrant is negative, negative. So when you go back over here, you're going to go positive again, but then you're going to go down. This is the root 3 over 2 comma negative 1/2. Okay, so if you, the reason we identify the bow ties or the short triangles all at the same time is because the x and y values are basically the same for those. You just got to be aware of when it's positive and when it's negative. And depending on the quadrant, that's kind of what you're looking at. The tall triangles are all the same as well. So you look at that, you've got the 1/2, the root 3 over 2. This is negative 1/2, but still a positive root 3 over 2. Back this way, this is your negative 1/2 and your negative root 3 over 2. And finally, it's your positive 1/2 followed by a negative root 3 over 2. The great thing about that is once you're dealing with your triangles, all the middle ones, you could just go right through. Anything that ends in a 5, 45, 135, 225, and 315, you can just go through and say root 2 over 2, root 2 over 2. It's a root 2 over 2 fest. Okay, as you go around root 2 over 2, root 2 over 2, and finally root 2 over 2, root 2 over 2. The difference is just this. If you get to know those guys, these are always going to be positive over here. But this one I had to go back first before I went up. It's a 45-degree triangle. It's called an isosceles triangle. Two sides are the same. Direction-wise, there's a difference. Here we're going back and down. There's a negative and a negative, according to that. Here it's a positive first, followed by a negative. So the positive, root 2 over 2, and then the negative. And last but not least, that was the last of the triangles, you have your x and y intercepts all the way around. You're going straight up. You didn't go back and forth at all. So you've got a 0 followed by a 1. You're going back all the way to here. You got a negative 1 followed by a 0. You've got directly down. That's nothing back and forth. That's 0 followed by a negative 1 down. And lastly, should have been firstly, over here to the right, it's a positive 1 and then a 0. That's the unit circle. Basically, sine and cosine are looking at the x and the y values of each one. So I won't get too much into it because I've used up too much space here as it is, but the sine of 30 degrees is like saying what is the y value. So the sine of 30 degrees is 1/2. It's the y value of the short triangle. The cosine of 30 degrees is the x value. It's the square root of 3 over 2.